Dr. Edmond Locard, a French professor, is credited with being the father of criminalistics. Locard developed the Locard Principle, which states, whenever two objects come into contact, there is always a transfer of material. This transfer of material can be on a macroscopic or large scale. An example of this is when you transfer makeup when hugging someone, or the transfer of paint from one car to another in an accident. The transfer could be microscopic, or so small that it can only be analyzed with a microscope. An example of this would be when fibers from a carpet are transferred to a body in the commission of a crime. Another example can be when a transfer is atomic, which is even smaller than the microscopic level. Examples of this would be transfer of DNA, toxicology, so the ingestion of materials such as poisons or drugs, items that require gas chromatography or mass spectroscopy to analyze, as well as using the scanning electron microscope to detect atomic transfers. The Frye Standard is based on the 1923 case Frye versus the United States. This is the first time the Supreme Court looked at methodology versus the credibility of the witness. This case set the standard for admission of expert and scientific testimony. The Frye Standard for admissibility asked whether the method had general acceptance within the scientific community. The Frye court said the proffered testimony could be valuable to the court. However, they must assure that the principles behind the testimony are, quote, sufficiently established to have gained general acceptance in the particular field to which it belongs, end quote. The Frye test was believed to be very limiting to any new scientific proposition that might be scientifically valid, but had yet to gain widespread acceptance in the field. In general, scientific evidence is allowed in the courtroom if it is accepted by the relevant scientific community. That means that you must be an expert in that specific field. For example, if you are an expert on DNA analysis, you cannot give testimony about the toxicology levels of a victim. Second, scientific evidence is allowed in the courtroom if it is derived quantitatively. We want to make sure that our experiments behind the science are quantitative. We don't want qualitative data because it is inherently biased. We project our desire for what the outcome will be onto the experiment, so it has to be based on numbers. Finally, the scientific evidence is allowed in the courtroom if the jury decides it can be used. The jury must decide if the evidence being presented is relevant or not. In 1975, Congress enacted the Federal Rules of Evidence, which led to confusion about the applicability and the survival of the Frye Standard. These rules govern the admissibility of all evidence in federal courts, including scientific evidence. The Federal Rules of Evidence ask whether a person is qualified to testify and whether the proffered testimony assists the trier of fact in understanding the evidence or determining the facts at issue. Many were concerned that the Federal Rules of Evidence were more liberal than the Frye Standard, and that they did not distinguish between what is or is not scientific testimony. Many states decided to remain faithful to the Frye Standard because it was already codified in their state law, or because of the general confusion of whether the Federal Rules of Evidence actually superseded the Frye Standard. This all came to a head in 1993 with the court case Daubert versus Merrill Dow Pharmaceuticals, and this led to what is considered the Daubert Ruling. Here the Supreme Court looked at whether Frye survived the Federal Rules of Evidence and for the first time specifically looked at scientific expert testimony. The court established that Frye did not survive the Federal Rules of Evidence. The court attempted to clarify admissibility standards by indicating that the trial judges must act as gatekeepers to determine whether the proffered testimony was relevant and reliable. The Supreme Court gave general observations that a trial judge can consider to help them determine the reliability of the proffered expert testimony. These questions have come to be known as the Daubert factors or the Daubert prongs. They are usually summarized as follows. Can and has the theory or technique been empirically tested? This means that it has been tested in a lab repeatedly. It shows accuracy of instrumentation or technique, and it's admissible because it can be repeated over and over and over again. Has the theory or technique been subjected to peer review and publication? The science must be peer-reviewed. If it hasn't been reviewed by a panel of peers, then it is not admissible to the court. The court should ordinarily consider the known or potential rate of error and the maintenance of standards controlling the technique's operation. The rate of error is going to be very slight. Nothing is 100% accurate. Even a DNA test has a percentage error. But in order to be admissible in court, the science needs to be 99.95% accurate. This means that only 5.05% error is acceptable in order for evidence to be admissible in court. Are the methods and techniques generally accepted within the scientific community? So, in other words, if you're reporting on analysis of drugs, then all analytical chemists must use and accept that same test in order for that evidence to be accepted into the court. And does it follow the scientific standards? A scientist must do the procedure scientifically. It must follow the scientific method, it must be documented, and it must be repeatable. These rules are much more stringent than the Frye Standard rules that were established in the 1920s, and this is what we use today.